so we got our new stuff. Nice Flex-Loc CK FL230. This is, I believe, a 20 series torch. I'm not sure. I don't know. I'm not a pro welder. I just know I like to do it. This is 25 foot. And the way this works is this plugs into the machine. The machine brings gas in, and then it diverts it out through that big bump right there. It comes out here. That gas then travels into the black hose on the TIG torch. And what happens next is it goes out through the nozzle. Now this right here, this is your water input. This water comes in near side and then flows down the connector. So need to be able to okay. So this is how this comes apart. These are all brazed in. Then what we got to do is we got to connect up the power. Get you a little better view here. This will go to the gas line. This will be your power cable. It's a little bit smaller, but that's because it's water cooled. It does not need so much. So this will thread in here. See the little notches right there? And right here? Yeah. Left hand thread. So don't think you got gypped if you can't get the thing to hook up right. That's how it hooks in. That's it. Do not put any pipe tape on here. This is supposed to be conductive. If you put pipe tape on there, you're taking away the electrical fashion of it. These connections are tapered at the tip. That's the sealing element. No pipe tape. Alright, so I got her fitted up. This is what's inside. This is the lead we just attached. This goes to the torch. This goes to the water. This goes out to the torch. And that's what's inside it. You just take this clamshell, fit it back in, close it up, and that's it. That's how it's hooked in. Fancy. Alright, so here we are at the TIG welder. Everything's hooked up. Hook the gas line up. That goes out to the torch. This is coming from the torch. This is coming from the connector. What we plan to do is run this up. And where this is going to go is up the side. And it's going to land at our cooler. And then the blue is going to go up to the cooler as well. And what the cooler is going to do is it's going to pump water into the blue line because it's cold. It's going to go to the torch. It's going to come back through the power lead right here, in here, through that little loop, and it's going to come out here. And this is our return line. This will simply get unplugged, and this one will plug in here. And it's just that simple. The difference is we are going to modify this. Like I said before, this is literally only a 10-second firmware, and that's too much gas flow for post flow on aluminum. So we're going to intercept this point. I'm going to get these threads off of here. We're going to run this pipe up, and that's going to go to the side, and we're going to have a controller so I can set how much time of post flow we get. And what that will do is it'll allow me to control the gas inside the welder, and this system will be able to work just fine. Or we will not put it up there just so it looks clean up top. We'll disconnect at the TIG, and we'll hook a controller to that with an incremental and decremental controller with a little touchpad so that we can turn it up by seconds or down by seconds. And we'll probably make it somewhere between 1 and 30 seconds. Alright, let's get to it. So, we got a little bit of stuff for the torch finally. We got our 7, our 5, an 8, and a 6 cup. we have those sizes. We got 1/8 inch, 3/32, and 1/16 gas lenses. And so that we don't have any kind of weird plumbing issues with everything, we went with these 5/8 18 for the inlet and outlet of the water. Left hand thread. See the notches? Left hand. So those are going to get plumbed in, so I do not have to run the water lines up to the body of the cooler without having any special parts. So with these, this will be 1/4 inch NPT, and this will be 1/4 inch NPT. And we'll drop that down the cart. We'll plumb it into the side with some hard line too, so it looks nice, and we'll be all set. But I did want to go up to 1/8 at some point, which I did this time. Never had to weld with 1/8, but also never turned the welder up past 165 amps. So with the water cooling system on there as a new feature, we should be able to actually use that for a while, which would be kind of interesting, because at first it always seemed like I could never use the whole welder because the torch would always die off every single time. Never have anything go right with it. But this time, kind of hoping we get a little bit different of an idea out of that expectation. Oh, and if you don't use these kind of collet bodies instead of the split ones, you should try these out. They stay nice and tight, they ramp up, and as they're getting tightened up, they cock sideways, so it gives it a much tighter bite, and you don't get that weird twist after you've been welding a lot with it at high temps. So I'll snug that up in here, and we'll put a 7 on there. 7 seems to work for pretty much everything out there. And that's it. Let's take this off. And this is the 3/32 tungsten, by the way. I'll just set that in there. Run this up in there. Bite onto that thread. And that's it. I could turn it, tighten it up, and it'll stay that way. Or just make little minor adjustments. But that would be for tight radius. The way I'm going to have it set up is actually kind of the same, but I've been mounting it on the back side of the bend. We'll get it where we want it. That's it. That's all you gotta do. And it looks pretty good too. It does have a hard stop, so I mean it doesn't feel like I'm just tightening and tightening and then just stopping where I feel like it's tight. It does stop pretty solid on there. So yeah, I don't know if you could see that or not. But if you look in there, you can see that collet is cocked sideways. You can see like right up in this area here, it's kind of protruding into that hole. That's how you get a nice lock on it. Wedges up there instead of pushing on the back, pushing all the way up, which makes it want to kink as it pushes. Pretty slick. I like it. So, I actually have an example here. If you take one of the split ones that I have in the original stuff, you can see the bulge. See how much worse that looks? It's all bent out of shape. And that would be one of the split collets. Oh yeah, got them nice and cleaned up. Nice and shiny for the new build. Oh yeah. Alright, so quick trick. I'm going to use these. Down here is going to be the TIG welder. It's going to pump vertically, so straight up the TIG welder. And I polish them all out so it looks pretty nice. But here's a trick that I don't think I've ever seen online or never looked it up, but this used to be round. But if you take a piece that's obviously not round, and you put it in a vise, and you give it just a little bit of force while rotating it, this will straighten your lines out. And see, makes it straight. Not a bad trick, not a hard one. Just takes a little bit of time. That's all it takes. Okay, so quick idea here. We're gonna have the inlet for the hot come down and around. We're just gonna hook it in like this, just straight into the copper. And then this is gonna sit right here, and it's gonna be held onto the frame. I'll screw that in once I get some connectors. And it'll come down here, and what'll happen is the blue and red lines will sit right there. There'll be one here and one over here. So they'll just sit side by side to each other. And then those will run up. And obviously this will be the hot side. It'll go into the tank, run through the radiators and fans. And eventually it'll get to the pump again when it's cold, and it'll pump out. This hose here, I'm going to run up and around to the back side, and I'm going to run it right next to this one, and they'll both go right down right here. So it shouldn't be too bad. Okay, so some of you are asking yourself right now, why in the world would anybody go through this much trouble for something that could probably be bought right on Amazon for probably significantly close to the price? I wouldn't wager that it's the same, but it doesn't make any sense why someone would spend so much time doing all this work when you could probably get something that's probably within $100 of this system online. And literally, for those of you that never done this before, you just literally hook them up. I mean, the connections are all the same, they're universal, everything is easy peasy. Well, the reason why is because I didn't start welding until about 2 years ago, about 3. And this was my quiet place. This is what I did to feel happy, took stress away. This was the way that I got rid of all of the possible annoyances or headache from the day-to-day. And you know what? It worked out really well. So I kept doing it. And this is how I like to spend my evenings anyway, is enjoying doing things like this that take a little bit of time, a little bit of effort. It's just enjoyable. So there's no reason, I guess, for me not to do it. When I got out of the service, there was nothing to actually do, and well, it turns out staying in one place for elongated periods of time is pretty boring. So this is where I went to, and it turned out to be pretty good. So that is why I'm spending all this effort to make this system work, because I like to build things, and this thing, well, I got too hot for the touch. So here we are, water cooling a welder that normally does not come with a water cooler, and it doesn't really have enough power to say it needs to be water cooled, but every torch that I've used that was a 17 always seemed to work on this thing. However, if you run it up to 160, 170 amps, the torch will start to smoke, and this thing never actually sees its thermal overload. I would like to run this at max power and see what it can actually do. In order to do that, we need to get the torch to survive long enough to do it. So if I can run this at 180 amps all the time, that will be a massive improvement if it can make it past 5 minutes while doing that. So yes, this is worth it, and it's fun. Alright guys, after 21 days, it's done. It's finally done. It worked out really well. Got everything insulated. Everything's hooked into where it belongs. Everything's working real well. This thing has been staying consistent. I've had it going for quite a while I wrapped up the cable. Everything seems to be running right. It's actually quieter by a long shot than the welder is. Everything's nice and smooth. There's no shaking from the pump pulsing. Everything looks pretty good. We are going to take the TIG 200 all the way to 200. We aren't going to play no games this time. We are going to see if this thing actually works. Alright guys, moment of truth. Here we go. We're going to try this without any water, and then we'll implement water, and we'll see if it cools down quick. This is 200 amps on AC. Alright, we're already starting to get pretty hot in here actually. Yeah, the cable's already getting hot. So let's kick on the cooler real quick, see how long it takes to cool down. Yeah, it's already cold. Let's give it a little bit more power into that throttle. Let's see what it does. Let's just go full bore. Get another rod and run it and see if it gets warm again after we use a whole rod. It's cold. I think we have a successful, yeah, that's a success. Well, this has been a fun build. Glad I could do it with you guys. And hopefully, in the near future, we get into the next project, which will most likely be a physics experiment with weapon silencers, and also a rotary welding table and gearbox. And we'll do that with the automation system. Glad to have you with me, and it's been fun. See you in the next one.